But that's okay. Here's what we're going to do on the test and on the sample test. We're going to do just a simple case. We're going to look at one triple and its list, okay? And we're going to do an explicit formula like we've done before. Now, last week when we did the explicit formula, we were trying to find the what term? That is the nth term. Okay? And yeah, I'll give you like a column of them, and you have to use it to make a pattern.
Did your dad understand what you were doing, or is he like?
Oh yeah. He's one of the top mathematicians who's alive right now.
So he's 251.
Very smart. He actually went through and did the formal proof because he didn't believe it. He was like, this can't work.
Is he ready?
He said, you're not going to solve a 4,000-year-old problem now at 27.
You said he's a...
So he did his little proof, and it all came together. He's like, I'll be darned. It actually works.
You said he's a professor, right?
Yeah.
Dean of Mathematics.
He is currently the number 11 ranked living mathematician right now. So he's pretty good. But, sure enough, they figured it out, proved it, we published it together, and the rest is history.
What are you ranked?
Not even close. Okay. I'm just a one-hit wonder. No, actually, we're going to do the other one tomorrow. I'm a two-hit wonder. That's right. Okay. So, here's what we want to do. Okay. First of all, we have our n column here. And we have our a sub n column. I wonder if we can write a pattern for all these. Now, do you see that these triples are coming from the height equals 5 column up there? Everybody see that? So this is height equals 5. That column, those are all the triples. And we're going to try to figure out the pattern. I picked an easy one because 5 is pretty much the easiest one, so we'll try this one. Okay, now, up in this empty space next to that Wade theorem rectangle right there, write down a little reminder. If there's not an obvious pattern, one thing you can do first
Simplify.
is look for a what?
Common factor.
Common factor. Let's put that down. Number one. Try to find a common factor because you can make big numbers into small numbers. Okay? What's the common factor here? 5. 5, all right? 5 times what? 3. 5 times? 5. 5 times?
7.
Ooh, I think I see a pattern. 5 times 9. All right, there is a pattern. So the a sub n term is going to be, what's in common? 5. Now the only question is, how do I get from 5 to 11, 4 to 9, 3 to 7?
Times 2 plus 1.
Wave the magic wand. Good, we've done that one before. If you multiply 2 times the n term plus 1, ooh, nice, it works there. 2 times 4 plus 1, does that work? Nice. 2 times 3 plus 1, yep, works all the way up, doesn't it? Perfect. Okay, and there'll be something obvious. So, when I get to the nth term, it is always 5, and this is going to be what? 2
N plus 1.
times whatever n is plus 1. And there's your formula right there. Okay? Just like the ones we did last week. All right, so that'll crank out all the a terms for the height 5 examples right there. Okay? Now, we have to get a pattern for the b sub n as well. And the c is easy. But the b is usually the most challenging. All right, so we've got 20, 60, and all these numbers. Any common factor here?
10.
4, looks like 10, we go to those. 20, we go to those. 20 is probably the biggest, yep. Okay, let's try 20. 20 times what?
1.
1. 20 times 3. So far so good. 20 times 6. Oh, nuts. 20 times?
7.
Oh, nuts. 20 times? 2 times what is 30?
15.
15.
2, 3, 4, 5.
Well, there is a little bit of a pattern going on. And here's the key. Everything we did last week was equally spaced, pretty much. Okay? If it's equally spaced, it's easy to write a pattern. That's 2, 3, 4, 5. It is a pattern, but it's growing, and it's very hard to do your magic wand and get from there to there if it's not equally spaced. Okay? So I wouldn't try to make a pattern out of that. It'd be very difficult. Instead, I have a second idea. And you won't use these anywhere else in the test except for in the Wade theorem problem. Okay? A little bit more sophisticated. Instead of doing the common factor, let's do a factor of n. Because it seems to work quite a bit. Here's what I want you to do. Instead of factoring out a 20, since we didn't get equally spaced, and you can't really do a good pattern out of that, Instead, how about this? Why don't we say how many times n goes into the number? There seems to be a lot of that in the triples. Okay, how many times does 1 go into 20? Okay, 1 times 20. How many times would 2 go into 60? 2 times 30. How about 3 into 120?
40.
3 times, oh, wait a minute. I see equal spacing. That's a good thing. How about 4 into 200?
4 times.
50.
4 times 50. I like it. 5 into 300? 5 times 60. Yeah. Right? So that means, you guys are too young for science, but anyways. Okay, so not equally spaced, not good. Equally spaced, good. Okay? All you have to do, now you can go back and do the common factor of these. Aren't they all just times 10? So 2 times 10, 3 times 10, 4 times 10, 5 times 10, and 6 times 10. Okay? And now you are ready to write your final answer. So the nth b term in this Pythagorean triple will be, how do you get 1, 2, 3, 4, 5? Isn't it just n? And then what is consistent throughout the whole thing? The 10. And then how do I get 2, 3, 4, 5, 6? You know what? It's n plus 1 every single time. So it's n times 10 times n plus 1. It's like doing 3 sequences at the same time, kind of like derivatives. Okay? Or, if you want to rewrite that as just 10n at a time. And I wouldn't distribute it, I just leave it like that. That's good. Okay?
5 minutes.
No problem, piece of cake. And the c sub n term is the easiest. What is the gap or the height between the b column and the c column in this entire example? Oh yeah, height was 5. That means that all the c terms are all the b terms plus 5. So that's just b sub n plus 5. That's the easy part. Okay? Because the gap's going to be the same all the way down. All right? Your challenge is to get that b column. The a column is pretty easy, but the b column, that's the challenging column. Okay? So I'll just give you like a string of these on the test, and I'll just give you one question where you do the a and b from those two. Okay? And pretty much if you follow these 2 rules, you're going to get them. All right? Now, let's do the odd case. 8's kind of an odd case. This is kind of like the worst case scenario. Okay? So let's start with the a column. All right, 20, 24, 28. Okay, what do you start with? What's your first
4.
guess? All right, common factor, 4. Great place to start right there. 4 times what? 5. 4 times 6. Oh, I like this. Anybody see equal spacing? Okay. Unlike this over here, where we had to do some more tricks, equally spaced, we're ready. So the nth term is going to be, what's consistent? 4 times.
N plus 4.
5 to 9, 4 to 8, 3 to 7, 2 to 6. Isn't that just n plus 4 every time? Okay, there it is. Usually the a's are pretty easy. Okay, now b is the challenge. So let's see what we got here. So b is going to be 21, 32, 45, 60, and 77. Okay, step 1, common factor.
3.
3. No. Not
Yeah, you know, some of these have 3, but not that one. Some of these have 7, but not
1.
these. You know what? There's no common factor except for 1. So skip that step. Let's do the factor by n. Remember that trick? So figure out how many times 1 goes into 21, 2 goes into that, 3 goes into that, 4 goes into that. 5 doesn't go into 77. I'm nuts. I was cooking when I was going through here until I got to that one. I was like, you gotta be kidding me. Here is the worst case scenario. Okay? If these 2 don't work, here's the last thing you try. Just factor the number. Factor in 2 things times itself. What's the only thing 77 could equal?
11 times 7.
Okay, 7 times 11, sure. Let's see, here's an obvious one, 21.
7 times 3.
That'd be 3 times 7, sure. Okay. Let's see, what about 32?
16.
Several ways you could factor that, but I'm trying to look for the pattern here.
2 to the fifth.
Okay, yeah, but just two numbers, just two numbers.
4
4 and 8.
What about 4 times 8? Oh, wait a minute. That might be a pattern. What about 5 times 9? What about? Oh, look at that. Interesting. Okay, those are the 8s, the crazy 8s. All right? So, the pattern is this. The B term is a product of two numbers. How do I get from 5 to 7, 4 to 6, 3 to 5? What's that?
Add 2.
That is n plus 2. And how do you get 5 to 11, 4 to 10, 3 to 9? That is n plus 6. And they were equal. It's just like doing two sequences at once is all it is. And those were equally spaced, and those were equally spaced, and we got it.
Yeah.
Huh, that's me. And then, of course, the C sub n term is simply the B term
Plus 8.
plus the height of 8.
Run something.
And that's the worst case right here. Okay? Just follow those three rules.
So you
All
just
right.
take the sum of those?
So then I had to find out the really weird ones like 288, 144, 57, all those weird gaps. Then I had to make one formula that took them all and put them all together into one big gigantic formula. But it worked. It was hard.
And it took you 12 hours to do it?
That's all that, yeah.